In 2023, a fintech startup faced disaster. Customers were locked out of their accounts, unauthorized transactions appeared, API keys were compromised. The cause? A misconfiguration in OAuth, a system trusted by millions. This wasn't an isolated case. Major security flaws, breaches, and misconfigurations have exposed OAuth's limitations. So, what went wrong? OAuth was revolutionary when it launched, but in a world of multi-tenant applications, dynamic access control, and increasing cyber threats, OAuth's broad permission model is no longer enough. This is the story of OAuth, how it changed security, where it's failing, and why solutions like Permit.io are redefining authorization for the future. To understand OAuth's challenges, we first need to clarify what it actually does. OAuth is often mistaken for a login system, but it's primarily an authorization framework. While it can be used for authentication, especially when combined with OpenID Connect, OAuth was originally designed to manage access permissions, determining what an application can do on behalf of a user. Authentication answers, who are you? Logging into Netflix with a password or fingerprint is authentication. Authorization answers, what can you do? Deciding if you can stream in 4K or only on one device, that's authorization. Or offers what enables applications to request access to specific resources without needing your password. Every time you log into a food delivery app using Facebook, connect a budgeting app to your bank, allow Spotify to post on your behalf, you're using OAuth. Instead of sharing passwords, OAuth issues temporary access tokens, granting specific permissions. But this is where the problem begins. OAuth was designed to grant broad permissions, not fine-grained control. Before OAuth, authorization was a security nightmare. If a user wanted to grant an app access to their data, they had to share their full password. This meant that if the app was compromised, their entire account was at risk. This problem became increasingly urgent as more web applications needed secure ways to grant limited access without exposing credentials. In November 2006, while working on Twitter's OpenID implementation, Blaine Cook realized that developers needed a better method to delegate API access. Around the same time, Larry Half, the founder of Magnolia, wanted a way for OpenID users to authorize Mac OS dashboard widgets to interact with his service securely. Cook and Half, along with Chris Messina, met with David Recordon, who had experience with OpenID, to explore how they could delegate authentication safely. They quickly realized that no open standards existed for API access delegation. Determined to solve this, the group launched the OAuth discussion group in April 2007, bringing together key contributors from the industry. DeWitt Clinton from Google joined the effort, expressing interest in supporting the initiative. By July 2007, the team had drafted the first OAuth specification, which was later refined and coordinated by Iran Hammer. On December 4, 2007, the final version of OAuth 1 was released. OAuth 1 revolutionized security by introducing access tokens, temporary keys that allowed apps to request specific permissions without exposing user passwords. But despite its success, OAuth 1 had a major flaw. It was too complex. Developers had to use cryptographic signatures for every request, making implementation difficult and prone to errors. To address these challenges, the OAuth community began working on a simpler, more flexible version. In 2012, OAuth 2 was introduced, removing cryptographic signatures, supporting different grant types, and making it easier to integrate across a variety of applications. OAuth 2 quickly became the industry standard, adopted by major companies like Google, Facebook, and Microsoft. But today's applications are far more complex than they were in 2012. With cloud computing, multi-tenant SaaS platforms, and evolving security threats, OAuth is showing its age. OAuth was built for broad permission scopes, but today's applications require granular, real-time control over access. Imagine connecting a third-party app to your Google Drive. With OAuth, you can grant it read-only or full access permissions. But what if you only want it to access one specific document? OAuth can be configured for more granular permissions, but its default model often grants broader access than necessary. For example, in Google Drive, OAuth allows access to individual files using specific file scope permissions, but many applications don't implement such fine-grained control by default. This is one of its biggest flaws. Scopes are too broad, users often overgrant permissions, creating unnecessary security risks. Additionally, OAuth's standard scope-based model does not natively support real-time, context-aware access control. However, when combined with additional policy engines, such as attribute-based access control or tools like Permit.io, it can be extended to make access decisions based on real-time factors such as user behavior, device security, or risk level. For example, an employee working from an untrusted device may require stricter access controls than one using a verified company laptop. But OAuth's static scopes don't account for these real-time conditions. And it's not just users, developers struggle too. OAuth requires multiple endpoints, token management, and strict security measures. A single misconfiguration can be catastrophic. In 2021, a major productivity tool suffered an OAuth misconfiguration. Third-party apps gained full email access instead of just reading permissions, exposing thousands of private messages. OAuth's limitations make it unfit for modern applications, where authorization needs to be dynamic and context-aware. So, how do we fix it? OAuth only controls what app gets access to what, but today's applications need to control what users inside an app can do. Imagine a project management tool. OAuth lets you define whether someone has access to projects, but it doesn't specify which projects, what tasks they can edit, or if they can invite other users. This is where Permit comes in. Permit extends OAuth's capabilities with fine-grained, real-time authorization. Instead of relying on static permission scopes, it uses policy-based access control, PBAC, to dynamically enforce rules based on user roles, relationships, and conditions. With OAuth alone, you can say, User A has edit access to all projects. With Permit, you can say, User A can edit tasks in Project X, but only view tasks in Project Y. Permit enables granular access control, defining specific actions instead of broad permissions. Real-time decision-making, adjusting permissions dynamically based on context. Seamless integration, with OAuth enhancing security without changing how authentication works. This prevents over-granted permissions, reduces security risks, and simplifies developer implementation. Organizations adopting Permit gain both security and flexibility, ensuring access control evolves alongside their applications. Even Permit.io and other authorization solutions must continuously adapt to new security challenges. OAuth isn't going away, but it needs to evolve. Over the last decade, the way we build and scale applications has changed drastically. Multi-cloud environments, API-first architectures, and zero-trust security models have become the new norm. However, OAuth was not designed for this level of complexity. One of the biggest shifts in modern security is adaptive authorization, where access is granted dynamically based on real-time conditions. Imagine this: you log into your work dashboard from a new, unrecognized location. Under traditional OAuth-based authentication, if you have an access token, you're in, no questions asked. But in an adaptive authorization model, the system analyzes risk factors. Are you using a trusted device? Have you logged in from this location before? Does your behavior match your usual patterns? If something seems off, extra security measures are triggered, such as requiring additional verification, limiting access to sensitive functions, or temporarily restricting permissions. This context-aware authorization is crucial for preventing attacks like session hijacking, token theft, and account takeovers. Another major shift is zero-trust security, which moves away from the traditional authenticate once, access indefinitely model. Under zero trust, every request must be continuously verified, regardless of whether a user has an active session. Instead of assuming that possession of a valid access token means the user should have access, zero trust applies real-time policy-based decisions that adapt based on risk. For example, an employee accessing sensitive HR records from an unfamiliar network might require just-in-time approval before proceeding. A contractor's access could be automatically revoked after their work contract expires, without requiring manual intervention. These new approaches go beyond OAuth's static scopes, which do not account for real-time risk analysis, user behavior, or contextual security factors. Companies like Permit.io are at the forefront of this transformation. By integrating with OAuth, Permit.io fine-grained policy-based authorization where permissions adapt dynamically based on real-world conditions. Centralized policy enforcement, making it easier for companies to manage who can do what without writing custom logic for every application. Real-time access decisions, allowing for role-based access control (RBAC) and attribute-based access control (ABAC) in a way OAuth alone cannot handle. As applications grow more interconnected, fine-grained, real-time authorization isn't optional, it's necessary. OAuth continues to evolve, but companies must adapt their access control strategies to keep up with modern security challenges. OAuth changed the way we handle access, but it wasn't built for the complexity of today's digital world. What started as a simple protocol for third-party access delegation has now become the foundation of API security across the internet. But OAuth alone is no longer enough. As businesses scale, relying on broad, static permission models creates security risks, compliance challenges, and operational inefficiencies. The future is fine-grained, real-time access control, where context, risk, and identity are continuously evaluated. OAuth laid the foundation, but solutions like Permit are redefining how we control access, ensuring that authorization is as dynamic and secure as authentication. In the coming years, organizations that fail to move beyond OAuth's outdated scope-based model will face increased security breaches due to over-permissioned applications, regulatory challenges for failing to implement granular access policies, operational inefficiencies, forcing developers to write and maintain complex, custom authorization logic. Meanwhile, organizations that embrace policy-based access control will reduce security risks by enforcing least privilege access in real time, automate access decisions, reducing the burden on developers and IT teams, improve user experience, allowing for seamless but secure access management. The future of security is already here, and it's being built by those who recognize that authorization must evolve beyond OAuth. The question is, will your application evolve with it or be left behind?